Hi, Geo people. So I am hoping that you guys are ready and you have a notebook out, and we are going to be taking some notes on inductive versus deductive reasoning. So you guys read that article that I gave you and hopefully have that summary in your head of what you think inductive versus deductive is. But in your notes, again, place this in table of contents. Inductive, and I don't know why I put that. Inductive. We're going to talk about that first. Okay? So in your notes, table of contents, inductive versus deductive reasoning. Chapter 2 starts off with inductive reasoning. So inductive reasoning, what I want you to know is that it uses patterns, okay, to draw conclusions. So that's a lot of the practice you'll be doing. You'll be looking at patterns and trying to come up with a conclusion. So you're writing that in. Another something with inductive reasoning is that you can't be sure your conclusion is valid. Cannot be sure that the conclusion is actually valid. It's just kind of out there. This is why the result is often called just a conjecture. So I'm just going to arrow it and say what you say the result is known as a conjecture. You're making a conjecture. So for example, we could look at the pattern of 1. So again, example. We could look at the pattern. It goes starting at 1, then it goes to 2, then it goes to 4, then it goes to bleh and bleh and bleh and blah, 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 right? So with inductive reasoning, some people might say that this next number would be 8, and then the next number would be 16. That's their conjecture, okay? And what's their reasoning? Can you figure out what they did? And you're like, well, yeah, I just did it. I multiplied this by 2, and then multiplied this by 2, and then that's the pattern, multiplying by 2 each time. Well, someone might conjecture differently. Can you come up with a different conjecture and a reason, valid reason to go with it? Yes, maybe not. But how about these numbers? They came up with 7 and then 11. Do you see what they were doing? So their conjecture is that 7 would come after 4 and then 11 would come after 7. So what they're doing is they're adding 1, and then they're adding 2, and then they're adding 3, and then 4, and so on. Okay, so as you can see with inductive reasoning, we can come up with multiple conjectures. What's important to take note of in inductive reasoning is that a counter example, super important, counter example, okay, disproves a conjecture. So if you're able to come up with a single example to show that a conjecture is not true, then boom, it's not true. So for example, let me get you to picture this. Let's say the conjecture is this, and I want you to try and come up with a counterexample. The conjecture is 3 lines on the coordinate plane, and I'm just going to abbreviate CP, coordinate plane, you know what I mean with the X and Y axis, coordinate plane, always form a triangle. Okay, so that's the conjecture. People are like, yeah, I did it 100 times. Every time the 3 lines formed a triangle. Well, can you come up with that counter example to disprove this conjecture? Did you already draw it? Because I got one. And that's this. Boom. 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 Haha, I just did it. 3 lines. It's not forming a triangle, people. Do I need to draw more counterexamples? Are there more? Yeah, there are. But I only need one in order to disprove it. Okay, so I could say the lines are parallel. Boom, they're not forming a triangle. And now you might be asking, all right, well, that was inductive, so what the heck is deductive? And if you're not asking, I don't care. I'm going to go through it because you need to know it. So deductive reasoning, this one's different in that it uses accepted properties. So we've already gone through some properties in chapter 1, so we use those as accepted truths. And postulates are used, and we've even seen some of those already. And theorems. Okay, so that's what you'll see in deductive reasoning. And they'll use these to create a string of logically connected statements. Sorry about my handwriting, but I'm writing with my finger. So we're using these three things to create a list of things that are logical and they're connected to each other of statements that we make. Okay? And we can actually conclude, our conclusion in deductive reasoning is valid. Okay? It is valid as long as the methods used to draw the conclusion are correct. Okay? So if you're not using the right properties, postulants, and theorems, then okay, you're not going to be valid. But if you do, you're going to be good to go. And there are two, so last thing, there are two laws of logic that we're going to be looking at in chapter 2 and 3. And I'm not going to go through what they are right now, but I just want you to know and have in your mind they're things that we're going to get to. So and they're kind of weird words. So the two laws of logic we're going to make use of one of them is the law of syllogism. Yeah, weird. Okay, syllogism. Yeah, law of syllogism. And that one, if you want to know right now what it is, I'm not going to tell you. You can look it up. And the second one that we'll be using is the law of detachment. Detachment. Okay? So as we're proving things, we might make use of syllogism or we might make use of detachment when we're making use of deductive reasoning. Okay, so that's a little idea today about those two reasonings that we're going to be using in the next couple chapters of geometry. And yeah, good job. Hopefully you took some notes. And on to the next thing.